And sorry to leave you on a cliffhanger there, but what you just heard will be fully finished at the very end of the video. So what you just saw was the automatic self-playing Kalimba version 2. So this was version 1, and it worked really well, but there was a lot of issues with it. So the major one being that it could only play about 1 octave, and the second biggest thing being that the servos were directly mounted on the Kalimba body itself. So when I try to record it being played, I would hear the noise from the servos, like the hissing noise, being emphasized greatly in the actual audio. So I need to get rid of that. So I designed a brand new version. So the brand new version was based on a linear actuator model. So I found this design for a linear actuator thing for a servo. So it had a straight gear and a circular gear, and the circular gear would turn to move the straight gear up and down. So first what I needed to do was design a 3-dimensional model for a Kalimba in 3-dimensional space. So I made a video about how to design this using only one photo. Click in the video in the top card or in the description down below. Once I had this 3-dimensional Kalimba designed in virtual space, I could position all my servos where they needed to be relative to each other so that they fit properly and didn't interfere with one another. Once those are all properly positioned, then I could design a frame to fit around it. So you can see here that I designed a base plate with a bunch of arms kind of sticking out to meet each servo at their proper position. And there's a little bit of a gap because I was going to hot glue these, so I was accounting for the space of the hot glue as well. So once these are all designed, I finished this up, and like this was the left side model, and then I also designed a right side model as well, but I'll save you the trouble of watching that. And you can see here at the very end I put a little bit of cutouts. That's just for registration so the pieces properly fit together. Once I had that design done, I needed to design the frame to hold the straight gear part. So I designed a little tooth thing to cut into the straight gear part, and then I printed it out, and you can see here that once I actually properly printed it out, they didn't actually meet up with the notes of the Kalimba itself. So it was actually way too big. So in fact, my calibration that I did initially was wrong, and I needed to redesign the calibration stuff. So I needed to go back into Fusion 360 and redesign my Kalimba model to actually fit reality properly and remeasure it. So I used the smallest measurement rather than the largest measurement, which is my mistake. So once I fixed that, I made a actual Kalimba model, and then I printed that out to see if it would fit reality. So this is the 3D printed part that we have. If we align this part with the middle note as best as we can see that the right side works perfectly well. Everything is pretty well aligned. However, the left side, right, the bottoms are all unaligned, but the tops are aligned. So that's probably because of the warping from the picture. So all we need to worry about, or the way that we can get around this, is to take the top part, this part right here, which is perfectly aligned with the top right there, and extend it down straight and perpendicular to this top bar. So this thing is curved, but if we send it straight down, we know that the gap is perfectly correct. So we can properly model what the Kalimba will look like in reality. And then using that, we can create feet that the linear actuator parts will match up against. So then they can, the first one will be angled this way, the second one will be angled slightly more, the third one will be angled slightly more, fourth one even more, fifth one even more. And so that way we can compensate for the miscalibration that we had. So now that we know exactly what's wrong, we can properly fix it and attack the solution directly. So we just need to make a bunch of rectangles for the left side of the Kalimba, because that's the side that's warped by the image, right? So now that that's properly done, we can just round off the edges, and we have a proper working model of the Kalimba in 3-dimensional space. Now we can use that to position our feet properly. So we're going to reuse that frame model that we had for the linear actuator part, where the little tooth sticks into the little cutout, and we're going to use that to make feet. So now that we have all 15 of those set up in 3-dimensional space, according to where the linear actuator, or like the straight gear parts are, we're going to make lines going from those individual feet to each individual note of the Kalimba itself. So we can properly customize the angle of each one according to where it is in this virtual Kalimba. And we know for a fact that this virtual Kalimba is correct because we printed it out and we measured it to make sure that it's right. So now we can properly design feet to fit onto the straight gear part of the Kalimba, and then just hot glued into place so they stay on. And now we're just designing a proper mechanism, little triangle, and then filleting everything just to make it look really nice and smooth and clean. So first what we're going to do is cut the servo horn with a hot soldering iron and make sure that no plastic sticks to it. And so the reason that we're doing is because servos have a really fine level of detail for their plastic gears that they have on top of them, and so the servo horn matches that to meet it. But we can't emulate that level of detail just with printing, so we're getting around this by using the servo horn that it comes with, the plastic little horn that it comes on top of it, and cutting it so that they can fit inside of the gears that we printed, and then hot gluing those little servo horns inside of each gear, and then hot gluing those gears onto the frame that we just designed. So here's what it'll look in final. You can see we have all 15 of them set up, and so each gear is sitting on top of the servo horn on top of the servo. So this is about a culmination of about a month's worth of work all coming into one. So I have a bunch of 3D custom printed parts, as you can see here, a bunch of screws, our Kalimba, servos, and Arduino Mega, breadboards, wiring. I'll explain how all this works together to create the self-playing Kalimba. So first, you can see right here we have 2 frames. So we have the feet, or I guess legs, right here, so that the whole mechanism is mounted away from the Kalimba body. An issue with the previous one was that the servos were directly mounted on top of the sound box of the Kalimba, so the sound of the servos would resonate to the Kalimba itself, and that would cause a lot of issues with the buzzing noise that you heard. So in this model, everything is mounted on top of it, away from it. Then we have our main frame right here, which holds our set of 15 racks, or I guess gear linear actuator racks, that match with our pinions or our gears right here. So this thing goes on top of the stand, or the legs, and then there's 3 screw holes for them to screw in. Then we have our 2 sets of gears. So you can see there's one here and one here, and there's a bunch of I'll probably do a close-up of this. You can see that there's mounting holes on the frame itself for these to fit into, something like that. And this one would also mount here, something like that. But you notice an issue, these things are kind of slanted, right? So that was a big problem that I faced, was that, I mean, also, you know, these aren't meshing with their proper, the pinions aren't meshing with their racks properly. So the gears are like this rather than, you know, meshing together. They're like this right now. So that, you know, involves some sort of adjustment. We can work that out. But the biggest issue is that these things slant backwards because there's nothing holding them in place at the top. So I needed to add this frame mount at the very top that would hook into this frame right here, hook into that area, and then support the top of these so that they stay aligned with the whole structure, so that everything properly meshes together, and also there's pressure on the top of them for the gears to properly mesh with their racks. And then once all that is assembled and screwed into place, then we can get into the wiring and programming. So let me just do a time lapse real quickly of me putting all this together, and then we'll jump into this. So now we're going to assemble everything together. So as mentioned before, there are 3 holes to screw the frames together, and then once those are properly screwed together, we're going to move all the racks up, all the linear actuator gears up, so then we can mount the 2 sides, the left and side gears, together, and then we're going to put on the top bracket to hold it in place. Now we see here, once we added the feet, that the whole Kalimba itself moves up when a foot presses down on a note. So we added little toes to these feet to flex and bend so that it doesn't push up the whole machine when we play the note. Okay, so I have this issue where when I put the Kalimba into this machine, the toes on the, I guess, legs or on the feet sometimes bite into the note too much and cause the whole like apparatus to push upwards because there's too much surface area of the like foot itself going into the note. So now I need to trim all these down so that there's like a angled tip rather than a flat tip, so that they don't bite into the note as much. You can see that there's like marks on all of these, right? That's because I shaved them all down a little bit to make them the proper length, but even that still didn't fix it. Some of them still bite in too much, and getting the exact length is not working out, it seems. So my solution is just to make it a pointed tip so that they don't bite into the note as much as they do currently. Okay, so there's this issue where the feet sometimes bite into the note so hard that they push the whole structure up, and then this thing pops out. So then these move back and don't mesh with the gears, and everything just falls down like these ones are right now. I can move them without them interfacing with the gears. That's really, really bad, and it's really annoying because that means I have to calibrate the whole thing yet again. So this is the process for me calibrating it. First, I have to take apart this whole structure. So I need to unscrew the bolts that you saw from before. Okay, now that I have it separated, I can take these out, put them down. Right, so now I have these all leveled. So I'm going to use the raft from printing the feet to move them up. I can move them up to a certain degree, and then I'm going to try to put the Kalimba underneath it. However, the Kalimba needs to be, so right now they won't fall through and they're all at the height of the Kalimba at the very base. But I need to move them all the way up and set these to their maximum points. So I'm going to take this journal that I have and put it underneath as a spacer. And that's going to move the Kalimba pretty much almost all the way. Let me get one, there's another spacer that I have. Oh yeah, this LED remote. Right, that's another spacer that I've been using. And that pushes all these sticks up to their near maximum level. So the second step is to go to all the positions, the initial starting positions of the motors, and set the entire left chunk to zeros, so you can see right here, and the right chunk to all 180s, because they're mounted like this. So one is facing the opposite direction of the other one. So these all need to be 0, these all need to be 180. And so now you'll see the codes being uploaded, and all of them move that way, which is the top position for all of them, because it's going to be faced upright like this. So these are all 0, and the other ones are all set to 180. Alright, now that they're set to their proper positions and everything is moved up to be as high as possible, now I need to mount these into their correct positions so that they mesh with their proper racks and gears mesh together properly. And they're also stabilized within the frame so they won't pop out again. Alright, so I got the top mounting bracket on, I got the screws, and you can see right here, and everything is stable, nothing is moving, nothing's popped out. So now I can remove the Kalimba and everything should stay upright. Yay. Okay, so now I have everything set in stone, nothing's falling out, right? So now I need to figure out what is the proper location for registration and positioning of all of these nodes. So I need to make sure that they all are the proper distance away from their corresponding node, and that they all travel the same amount of distance that's needed, plug the node properly. So it's not perfect. You can tell that not all the notes are being played at the same dynamic. However, all of them are still being played. So that's good enough for me for now, because I need to put out a video of this working finally. I'll adjust the feet and the toes or whatever and sand them down later at a later point. But for now, this is what I'm going to be using to play the rest of the music throughout the rest of the video.